All right, so last time we looked at graphing reciprocal functions, but they were linear. So today what we're going to look at is quadratics. Now, I have right here that you can see really quickly some examples of what these graphs look like. They are more complicated than the linear versions, but they work the exact same way. So let's go through how we set these up. This is the process, and let's go through an example first, and then we can look at like what these different graphs look like. So it's the exact same process. The first thing we do is graph it as if it was not a reciprocal graph. So we have here the equation we want to graph. Instead, we're just going to do it y equals x plus 1 and x plus 3. Right? So I know my roots are going to be at -1 and -3. I know that my vertex is going to be between them. It's a smiley face. It's down. It's there. And that was 1 up 3. Cool. I have my graph. I'll go one more just to make it be clearer. Cool. So I have all my points. Awesome. The other thing I want to do is put the asymptotes. I actually put this as an earlier step. You can do it after. It doesn't make a big difference. The way you can tell the asymptotes in the equations we're doing now, y equals 0 is always an asymptote, so I know it's not going to be on that line. Let's make it a dotted line. Okay. The other asymptotes are going to be the NPVs for x. So I know x can't equal -1 and it can't equal -3. As we learned from last unit from looking at this and looking at this. So it can't be -1 and 3, which you'll notice are the roots. It makes it a lot easier. So -1 and -3. Remember, asymptotes are a value where the graph is going to come close. It's going to get close to it, but never actually touch it like that. Okay? So now what we're going to do is we're going to take all the points that we still have and we're going to find the reciprocals. As well as that, we're going to keep the points that are at y is 1 and -1 the same. So right here, I have a point here at the vertex. That's actually a -1. That's going to stay the same. I'm going to draw my line to connect them, just so we can see the basic graph, like this. Okay, maybe make it a little bit better. Whoa. So now, the values for 1, which we can see are here and here, are approximate, so that's okay. We're going to leave those the same. The pink's going to be my final answer, okay? And then we got to find some other values. So let's look, this one's at 3, so the reciprocal, that's going to be a third, so it's down here. This one's at 8, so the reciprocal is 1/8, it's small. And again, same with this one's a third, this one's an 1/8, cool. So I know I have my curve going like this, and going like this. I know I have my curve going like this, going like this. So those two parts we just did look very familiar to the linear ones. This one at the bottoms where it gets a little trickier. We have to think, okay, what am I going to do? Either this graph is going to curve up or it's going to curve down. Honestly, the way you can kind of tell, it's going to go different direction from where the line is right now. Because as we can see, like this point is at like half. So it's going to become 2. And then we can very clearly see the curve is going to go this way. Again, it's going to curve and not touch the asymptotes, but just continue on, making that weird kind of, it's not a parabola, but making that weird kind of semicircle shape, oval shape, whatever you want to call it. So that is our final graph. That's what it looks like. I want to just take you through some examples without actually graphing them just so we can see it. And the process was exactly the same, right? We graphed the normal graph, that parabola we had, the green one. Then we put the asymptotes, those blue lines, to help us indicate where it won't go. Then we actually find the reciprocals of points. So those values we flipped over from this to half, or from 1/8 to 1/8. Then we put the POIs that were the same at 1. So this ended up being the vertex. Not always, but it is the vertex here and those 2 points. Then we connected the points to the curves. The last thing we should do is erase the normal graph. So that parabola should be gone, and it should just be the pink parts left. So you can erase it or whatever you have to do. I like showing it just so you can see it. So let's look at these 3 examples. In the linear ones we did, it always looked like this, or it looked like this, okay? The quadratics, there's going to be 3 basic types of graph, and it depends on the asymptotes you have. This is the original parabola. It could be this way as well, and you'll notice that it doesn't have any roots. That's why the parabola looks like this with no vertical asymptotes. This is the parabola we just did, where it has 2 roots, right? So you can see here and here. That's when it has 2 vertical asymptotes. So it makes this kind of weird, I don't know, it looks to me like a sad face. 2 eyes and a sad face. Okay, the last one is where there's only one vertex, one point of intersection with the x-axis, one root right there, and so that has one asymptote. And so it looks kind of like the linear ones, but a little bit different. So the process for finding these, for graphing all these, is the exact same. You have your graph, and then you take the reciprocals of all the points. The one's going to stay the same. This was at 2, it becomes a half. This was at 2, it becomes a half. I look at my asymptotes. My asymptote is here, and there's no vertical one, so I connect the points in a logical curve, not touching the asymptote like that. Done, graphed. This one we did already is the one below. Let's do this one. So we have our graph, okay? Then I have my asymptotes, cool, okay? Then we're gonna take the values at 1, 1, and 1, and we can take some other ones if we want. So like this point's at 2, it becomes half. Oh, sorry, on the parabola. This point's at half, so it becomes 2, that kind of thing. Where is it? This point's at half, so it becomes 2. And then we connect the points in a curve. Cool. This graph would be easier if it was a little bit more zoomed out, so we'd have more points to work with, but that's the process. The only other skill you need to know is how to take a graph and turn it into the original parabola it was. So like take a reciprocal graph and make it into a non-reciprocal graph. This part's a little tougher, and if you have to do it, it will have a lot of points labeled. So for example, this one only has this point labeled, but it should have more. It works the same way. We do it backwards. So we say, okay, what are the asymptotes? I know there's this, which doesn't really help me, -1 and +1. So because it has -1 and +1 as its roots, I know that the parabola is going to have x + 1 and x - 1 as part of the equation. The only other part you need to figure out is what the a value is going to be. So you know that this is a point, and this is a point, and the values at 1s are a point. So this is actually 1, this is 1, and this is 1. These are kind of inaccurate points, so I'm not going to use them. But if I connect these points together, I can see the parabola forming. I know that it went over 1, up 1, which means that the a value is going to be 1. So I have my entire equation done right there. That's the process. There are harder questions, but that's the basic idea. Take your asymptote points, take your points at solid points so you can find the reciprocals if you need to, and then fill in the values with what you have. I think for this type of question, the hardest ones are these because they don't have roots, but you can still do it based on if the graph is detailed enough with points given. And that's it.